Hello and welcome to class today. Obviously, I'm not going to be here for you guys, but I thought I'd lay out a lesson so that you can be successful today and learn about systems of equations and how we can solve it. We've already warmed up with a couple things from last class when we talked about how to write equations based on story problems and to solve where kind of two situations meet when we're talking about the tree problem that we did in the last class, where they were the same height. That's the idea that we have here. But before we get started, I'm going to give you guys a warm up right here. So I'm going to ask the sub to pause the video here and let you guys have 2 minutes to solve these two problems. The first problem, you need to solve for y, which means get y by itself. So undo the things around it. In the second problem, we're going to solve for r and then get r by itself. Go ahead and pause right now, and then we'll show the solutions in 2 minutes. All right, let's see how to solve these. Hopefully you've gotten a chance to do that, and you can solve this with me right now. So on the first problem, we're going to try and get y by itself. When I do that, I'm trying to get rid of all the things that are around it. So I'm going to get rid of the 12x by doing the opposite of the adding 12x that was over here going on. I get rid of that. Now I have 3x over on that side. So 3y, is equal to negative 12x plus 21. Now I still need to get the y by itself, so I'm going to get rid of by doing the opposite of what's going on there with the 3. I do division, and I have to do division on all of these. Now I get my answer as y is equal to negative 4x plus 7. Over on the other one, we're now solving for r. So I'm going to undo things that are around the r. I can first start off by getting rid of these things that are being multiplied by it. Now I can do it one at a time, or I can also just multiply by 4 pi, divide by 4 pi on both sides. That's going to get rid of the 4, get rid of the pi. Now remember we said that it doesn't have to look pretty when you're dealing with solving for a variable. It's okay to have things that are divided and kind of look weird. Now we have r squared, and r squared by itself is going to be something that we need to undo. So we're going to undo this r squared. Now the opposite of a square is a square root. We haven't talked about that, but it's something that's common in math and will come up. So now the undoing of r squared gives us the square root of a over 4 pi. And that's how we leave it. R is equal to the square root of a over 4 pi. All right. All right, good job. Let's go ahead and jump into our first problem here. So I'm going to read this along with you. And it talks about setting up a system of equations. All right, and we'll talk about what a system of equations is as we kind of go along. A system of equations is 2 or more expressions or 2 or more equations that represent some kind of situation. They could be like the tree problem that we did before that represent the height according to the year, or it could be a problem that is just purely variables and doesn't have anything associated with it that we know about. All right. So what we're going to do is we're going to take a look at this problem right here. It's time to cool off on a hot summer day. Team Sunshine is filling an inflatable kiddie pool with a garden hose, and the pool has 30 gallons in it. And Team Sunshine is adding 8 gallons per minute with the garden hose. Next door, Team Breeze, their pool is already filled with 180 gallons of water. And they're emptying the pool at 5 gallons per minute with buckets. Write an equation to represent the situation and use the equations to find how long it takes until both pools have the same amount of water. All right, so we need to take a look at the two situations that we have. We have a situation for Team Sunshine. We need to find out what we know about it, and a situation for Team Breeze. So let's start this off. what is the information that we know about Team Sunshine? Well, let's think about it. We know that Team Sunshine is starting out with 30 gallons of water. So that's our starting point. And their growth, it is bringing in 8 gallons per minute. All right, I think it says minute. Yep, 8 gallons per minute right there. Team Breeze is starting out with 180 gallons, and their growth is actually not growth. They're losing 5 gallons per minute in buckets. So what we're going to do is we're going to try and write an equation that works for this. Now, I'm going to write the equation in 2 different ways. I can write it as a variable with x and y. So I can do things with x and y if I get my pen to work. So I could write this the way that we know. Y is equal to the growth, which is 8 gallons times x, plus the starting point right there, 30. I can also write it for different variables. Let's say we're talking about, in this case, G equals number of gallons that we have. And we can also say, let T equal time in minutes. That gives us a different set of variables, which is fun to use. So we're going to say G is equal to 8 times T plus 30. And this really checks out because if I say we want to find out what it is after 1 minute, that's going to be 1 times 8 plus 30. So that's going to be after 1 minute, there's 38 gallons. Over on the other one, we can write that equation too. And that equation's starting out at 180. So we're going to say y is equal to negative 5 times x plus 180. If I was to write it with gallons and time, gallons is equal to negative 5 times t plus 180. Now, I want you to see both of these sets of equations as being valid because you're going to see them in y equals mx plus b form, but you're also going to see them in other variables. Don't be afraid of the fact that we have g and t or any other set of variables. They mean the exact same thing. They work the exact same way. Now, we want to find out where these equal each other. So basically what I'm saying is I want to find out where the gallons are the same. Well, if I want to know what the gallons are the same, I'm basically trying to say, okay, where's my pen? Come on, pen. There it is. When this is equal to this. So we're going to set them equal to each other. We're going to say, come on, pen, 8t plus 30 is equal to negative 5t plus 180. So essentially, we've taken what the first thing is that g is equal to and making it equal to the second equation, what g is equal to. So when the water level, G, the same as in these two pools, we can solve this system. So we're going to solve it by finding T. So plus 5T on both sides. And we're going to end up being 13T plus 30 is equal to 180. Subtract that 30 from both sides. And we have our 13t is equal to 150. And divide by 13, divide by 13. Now, I'm going to jump to my calculator here. I'm going to get that answer because it's not going to come out perfectly. 150 divided by 13 is going to give us about 11 and a half minutes. All right. Now I can write it two different ways. 150 over 13 could be my time. And it also could be written as 11.5. And we're rounding it off. Both of these are in minutes, and these are both where they're equal to each other. All right, this is both where the pool on the left is equal to the pool on the right. Now let's just double check to make sure that this actually works. Okay, so I have that 150 over 13. So if I take that, I'm going to plug it in to both of them and find out what I get. So the number of gallons I get right here. Eight times 150 over 13 plus 30. And so I take that times 8 plus 30. Let's see if that's equal. 122.3. Now it's not pretty, but that's fine. We're going to try the other one and make sure it's equal to the same thing. So that's gallons is equal to -5 times 150 over 13 and plus 180. So I'm going to take -5 times 150 over 13, get that answer, and then I'm going to add 180. And there it is. The gallons are equal to 122.3. And we've rounded it off there, but we've seen that that's the same. Now, the gallons are this. It's not a whole number, but that's okay. And the time is this. A lot of the time we write our answer as a point. When we write our answer as a point, it's going to be the x value, or in this case, the t value, and the y value, or in this case, the g value. So this is called our solution. All right? Now, we have to look back at the question and say, okay, how long does it take until both pools fill with the same amount of water? That's going to be the thing that it's asking. So the answer is really the time for this particular problem. Now, not all of these come with a story problem. So let's take a look at another problem here. I want to solve this system of equations that is right here. All right, I've written it out to the right here and here. So we're going to solve both of them by solving them for y each. Now the first one isn't solved for y, so I need to go ahead and get y by itself. So let's go ahead and do that right here. Get y by itself. And then I'm going to set it equal to the other one because I already have y by itself right there. I'm going to give you guys a minute. Substitute, if you wouldn't mind pausing, give it 1 minute and solve the first one for y. All right, so now we need to get them equal. Hopefully you've got y by itself, and the way we do that is get rid of the other things around it. I'm going to get rid of the x by subtracting it. You'll notice how the x is positive up top, so we just need to be negative or minus to get rid of it. We have -2y is equal to -x plus 4, and I'm dividing everything by -2. So I get a fraction of y is equal to, I can separate these, remember, x over 2 plus this right here is 4 over 2, or -2. The other equation we had, y is equal to -1/2 plus 4. So since these are both equal to y, I can take this, which is equal to y, and this, which is equal to y, and set them equal to each other. So that x over 2 minus 2 is equal to negative 1/2 of x plus 4. All right. So now I'm going to solve this. I'm going to add, by the way, this is also the same thing as 1/2 x. So if I add 1/2 x to both sides, I'm going to end up with just 1x. And it's equal to 4 on this side. And so adding 2 to both sides gives us x is equal to 6. Now, this is not my full answer because it's only one of the variables that we have. What we need to do is plug it back in to see what the other variable is. So I have y is equal to, I can pick any one of the equations, but I'm going to pick the one that was originally given to us. Y is equal to negative 1/2 times 6 plus 4. That's equal to negative 3. And y is going to be equal to 1. So what is the x value? What is the y value? We put it in a point. It is 6, 1. This right here is our solution. Now, what does that mean? Because it's a solution, that means that it's something that works for both of these equations. If I plug that solution into both of the equations, the original equations up here, they're going to give me a true statement. Let me show you what I'm talking about. If I plug that solution into the first one, x minus 2y is equal to 4, it should give me 4 on the left side of the equation. So I plug in the 6. I get my pen to work, maybe. All right, come on. There we go. I get 6 minus 2 times y, which is 1. And lo and behold, it equals, and so it works. Now I need to check it for the other equation and see if that works too. So I plug into the other equation, and guess what? It's going to work also. Y is equal to, let's double check. We plug in, there it is. Y is equal to 1/2 x, negative 1/2 x plus 4. There it is. I believe that's the one. Yep, negative 1/2 x plus 4. And if I plug in 1 for y, and I plug in 6 for x, I'm going to get 3 plus 4 is equal to 1. So I've double checked it to see if it works. This guy is my solution to this system of equations. All right, let's take a look at another problem. I'm going to give you all about 4 minutes to solve both of these for y. All right? 4 minutes to solve both of these for y and see if you can't set them equal to each other. I'm going to give you about 3 minutes, so if the sub can help me out and pause. The hint here is get y by itself for each. Okay, so get y by itself for this one and get y by itself for this one. 3 minutes to solve both of those for y. Do that in your notes right now, and then we'll come back and I'll give you a few more minutes to try and get what the solution is, that point that is the solution to this system of equations. Pause now. right. Welcome back. Let's see what you got. If I want to get y by itself here, I need to get rid of all the things around y. So for the first one, I get rid of x. Now I have this. I need to get rid of the 2. So here's my equation. It's solved for y. Y is equal to negative 1/2 x, or negative x over 2, plus 7. Over on the right here, I'm also solving for y. I need to get rid of the things around it. So let's add x. And I get 3y is equal to x plus 26. And y is equal to 1/3 x plus 26 over 3. Now, this has some fractions in it, which is okay. You've solved for that. 26 doesn't go into 3 evenly, and we have some fractions of 1/3 and 1/2. This is going to present a bit of a challenge, but there's a way that we can deal with it. Now that I have this, I want to set these equal to each other. Okay, so I'm going to ask that, I'm going to set it up real quickly, and then I'll ask you to pause it and see if you can finish out to solve for that point that is going to be your solution. Okay, so let's set this up by saying what they're equal to. I know that this is equal to y, and this is equal to y, so I'm going to plug in 1 for the other. I'll set it up over on this side, where negative 1/2 x plus 7 is equal to 1/3 x plus 26 over 3. And so if I'm trying to solve this, you might remember what we did, I think it was in December, maybe in November. We were solving equations that had fractions in them. And we went for a way to get rid of all the fractions. It was our fraction buster. Now think, what would be the fraction buster that gets rid of both the 2 on the bottom and the 3 on the bottom when we multiply it on both sides? It's going to be our common factor, or really our common multiple of both 2 and 3. If you're thinking of 6, you're right. We multiply everything by 6, and it's going to get rid of both of the fractions. Here we get negative 6 over 2, which is 3, and 42. On the other side, when we multiply in the 6, 1/3 times 6 is going to give us 2x, and this is going to give us 6 divided by 3 is 2, and 2 times that is going to be 52. This looks like a lot easier of a problem to solve. So I'm going to do it. I'm going to continue with this. I'm going to subtract 2x from both sides. I'm also going to then subtract 42 from both sides. And now I have this goes away, negative 5x is equal to positive 10. I divide both sides by negative 5, and I get x is equal to negative 2. That's one part of my solution. Remember, that's the x part of my solution. What do I have to do to try and solve for the y part? Well, I got to plug it into one of the equations. Now I can plug it into the equation that I solved for, or I can plug it into the original equation. Either way is perfectly fine, as long as you haven't made any mistakes along the way. Here we get this, plus 7, and negative 2 times 1/2 is going to be a positive 1, plus 7 is going to give me 8. So y is equal to 8. So there's my solution. Now, I got to double check to make sure it is really a solution to this problem. So I'm going to plug it into one of the original problems. I'm going to plug it into the first one of x plus 2y is equal to 14 and see if that works. All right, x is -2, y is 8, and -2 plus 16 is equal to 14. So it checks out. We can double check the other one also, but that's the way that we're going to get our solution. All right, we can do a lot with these. Now it is, as you can see right here, it is a lot of work. Each problem is kind of building on the fact that we're solving equations and we're simplifying equations and we're plugging things in. So you'll notice how there's a lot to be done here, but there's a step-by-step process. The first thing, we got both of them equal to y, and then we used that to create a new equation that we could solve. The next step, once we get one solved, one variable, we're going to get the other variable by plugging things in. All right, let's take a look at another one right here. And when we take a look at another one, it actually brings up something from the book, which is a math note. And that's just a way that it explains everything going through. All right, so you can take a look at the notes that are in the math section, and hopefully it can help you to remember exactly the steps to take to get to the next thing. All right, so here's another system of equations, and I'm going to give you guys a little bit of time to work on this right here. Notice how we have, actually, is this one set up the same way? Oh, it's not. It's not the same problem. Notice how we have one of them that's solved for y and one of them that's not solved for y. This right here presents a new way of doing things. We can try something new here, and that is called our substitution. Instead of solving this for y, there's a shortcut. I can actually take this and plug it in for the y right there. Now, normally, I'd gotten this to be y is equal to, and we bring the 3x over to the other side, and so we get -3x, and then -13, and then we divided everything by 5. So this is the way that we'd done it before, and we set these two equal to each other, because this is the first equation, and here's the second equation. Here's the second equation solved for y. If I set them equal to each other right here, I can solve for x. But I can also do the same thing and save a step by plugging in for the other. So let's do that. 5 times, instead of y, -x minus 7 plus 3x is equal to -13. This is called substitution. And it means that we only have to solve one of them for y, or one of them for a variable. When I do that, I probably have some distribution in most of these problems. So I'm going to get -5x minus 35 plus 3y, or x, is equal to -13. I now can add these together. -2x plus 35 is equal to -13, and solve. Bring the 35 over to the other side by subtracting. We get 48, -48. And so when I divide, I end up with x is equal to +24. Remember, that's only half of our solution. The other half, get y. So I plug in that 24 right here, and I get y is equal to -31. So again, my point, 24 negative 31 should be a solution to both of these. All right, we can double check by plugging it into both and seeing if it is a solution to both. All right, so that's the idea that we have here today. I'm going to give you guys some time to work on the problems that go along with it. I'm going to give you one more problem right here. This is actually the same problem that we had right there. Just gave myself a little bit extra room. This is the assignment, and I'm going to give you one more problem that we have right there to work with. If the sub has time, you guys can do it now in class and then go over it. If you don't, then you all can add it on to our homework section right here as a second problem. All right. The homework that you have, a little bit from the book. There are 5 or 6 problems from the book, and then a set of problems on solving systems of equations in Delta Math. All right. Remember, bring your homework questions to class next class, and we'll go over them. All right. Here's the last problem. If you guys have more time, so you guys can work on this right here. And if not, just add it on to the homework right there that's posted up on Canvas. Make it a great day, and we'll see you all next class. Take care, everybody.